So just below here, we have just a couple of examples of that. And so we'll run those ones through. Now we're going to be using electron current for all of those. So for all the ones below, you want to use your left hand and just put your paper down flat on the desk, and then we'll orient everything relative to there. So on our first one here, our current is this dot, so that's coming directly out of the page. So the thumb of your left hand is coming straight up out of your page. Your fingers are the magnetic field, so that's pointing to the left side of your page, and that puts your palm then facing the top of the page, and so we can put our force vector in right over there. These ones here, we see our current and our magnetic field running parallel to each other, which just means then that the force is equal to 0. Now here they're 180 degrees apart, they're moving in the same direction, that would give you the case of 0. It doesn't matter if it's 180 or 0, if they're parallel, there's no magnetic force. On the next one then, we're going into the page, so the thumb is pointing straight down into your page. Your magnetic field lines are pointing to the top of your page, which puts your palm then towards the left side of your page, and so our force vector will be there. On this one here, we'll put our thumb towards the top of the page. Our fingers are going to be towards the right side of the page. That has your palm going straight up outside, and so then we'll use the dot, since we'll use that cross-section one there to have that force coming directly out of the page. For this one here, my current is towards the bottom of the page, so I'll put my thumb towards the bottom of the page. My magnetic field is coming straight up, so put your finger straight up out of the page, and that puts your palm then to the right side of the page, and so that will give us a force vector over here. And for the last one, our thumb towards the right side of the page, and our fingers pointing down into the page, and that puts your palm then towards the bottom of the page, which is where that force line then is going to be drawn. Now for this next set, we're looking for the direction of the current. So our force is towards the top of the page, so our palm is going to be facing then the top of the page. Our fingers then should be pointing then towards the right side of the page, and what that's going to do then is it's going to keep then our thumb pointing straight down into the page. So palm towards the top of your page, fingers towards the right side of your page, and you'll notice then that your thumb is pointing down directly into the page. And so then we'll use that cross-section notation, but going down into the page, and so our current then will have the x value there. For the next one then, our palm will be pointing towards the left side of the page, that's along the force arrow, and our fingers now will be pointing directly down into the page. Your thumb should be pointing down towards the bottom of the page, and so that's going to be your current direction then for that one. So palm to the right, or palm to the left side of the page, fingers pointing down into the page, and that puts your thumb then pointing towards the bottom of the page. In the last one then, we'll put our palm towards the top of the page, so that's along the red arrow there, so palm towards the top of the page. These dots then, that's the magnetic fields, that's coming directly up and out of the page, and so that then puts your thumb pointing towards the right side of the page for your current value. Now for this one, I'm going to solve actually part B first, then we'll come back to part A. You could do them in either order, but we'll just run it in that order. So we have a conducting wire that's 32 centimeters long, has a mass of 56 grams, and we're putting it in a magnetic field. And so what we're looking to do is to have it levitate there just in one place. And if it's levitating in one place, we have kind of a wire sitting like this, I have of course a mass, so my force of gravity is going to be pointing down. And so if I want it just kind of to levitate in the air, I need an opposing force going in the opposite direction. Now with this magnetic field, if it's stronger than the force of gravity, I could accelerate that wire up. If it's less, I could have it accelerating down, but less than the falling speed of 9.81 meters per second squared, or I can have it just levitate in place where those two forces are equal. So in that case here, if I'm looking for the current for that to be required, I can just take my force of gravity equals force magnetic, or I can do the force net equals force magnetic minus force of gravity, and then the force net is going to be equal to 0. My force of gravity is just mg, as always, and then my force magnetic will be this ILB equation. And what we're looking for is the current, so that'll be our letter I. So mg over the length times my magnetic field will be equal then to the current that's required. So do make sure you are working in meters and kilograms, and so we'll take the 56 grams, and that becomes 0.056 when we put that into kilograms. Our G value is the 9.81, as it always is. The length, and we want to be in meters here, so 32 centimeters. That'll give us 0.32 meters. And our magnetic field is given as 0.65 Tesla. And that'll give us our current. And our current then, for that particular one, will be 2.64 amps. Now going back to the first part of the question there, where we're looking for the direction of the magnetic field, we see that my force of gravity is always going to be pointing down. So if I want to levitate this, my force magnetic has to be pointing up. And so that's what we're going to be looking for this one here. So our current, we're told, is going to be running north. So we're going to put our thumb north. So we'll take that to be the top of our page. So put the thumb of your left hand pointing towards the top of your page there. And then what we want is we want then our palm basically pointing directly up from on top of the page there. So remember, that's going up straight out of your page. So thumb towards the top of your page, and your palm should be pointing up out of your page. That would be basically then counteracting the force of gravity. And that leaves now your fingers pointing to the right, which is going to be our direction east. And so for this one, then we can say that if our current is running north, the magnetic field direction is going to end up being east if we want that to counteract then the force of gravity. And of course, this one here, I've drawn this flat into the page, but remember, this force magnetic would be coming directly up and out of the page, and this force of gravity then would be pointing down then into the page for that one there.